So now I'm ready to actually run a sample. I'll start the pump. Pump right now is off. It says stand by. Here, if I cover my mouse there, it says turn device on. So I'll click there. I hear the pump start. Right now it's 50% water, 50% acetonitrile. It's running at 1.2 mils per minute. That's all determined by the method. Esther's method already tells it what to do. I'll let it run for a couple of minutes. I can look down here and see whether it's flat. It should be a nice flat, this is a UV detector, it should be a nice flat line. If it was changing, I would not want to start my run yet, because this is how I detect when a molecule has come through the column. So I have my sample here already injected in the loop, just waiting for me to flip the switch to inject the sample into the column. On this side, on the computer side, everything looks good. The pressure is reasonable, it's less than 100 atmospheres. If it got up to 200 atmospheres, there's a problem. We should shut down the machine. Here this is flat, so I'm ready to go. Before I start my run, I'll click this. Here it says balance. That will make the absorbance reading 0. So it's like baselining your cuvette in a spectrophotometer. Say yes. Okay. Alright, so now it should be set up ready to go. I will, on the HPLC side, I will flip this lever down. Once I do that, on the computer side, this turns to blue, it says run. This turns to blue, it says run. There's a counter here that says we have started the run. Professionals have much longer methods than 7 minutes. We're doing a hurry up version because we have so many people who want to use the machine. You can see the solvent is starting to change its proportions. So it will go up to 100% acetonitrile within a few minutes. Down here in the lower right corner is where the data will appear. So if I've chosen my wavelength correctly, when salicylic acid comes through the machine, through the HPLC, I will see a peak appear. And it'll appear at a certain time. That time is called the retention time. It will be very, very reproducible. If I run the same method with salicylic acid, it will come out at precisely the same time. So I'm looking for a peak here. There's a peak. There's a peak. There's a peak. Okay, and you see it's very sharp. It had a very specific time, and now we're back to this flat baseline again. In this case, the peak goes higher than the scale, so you can see the scale here. That I can adjust with these up and down arrows. So if I click up, then the peak becomes on scale now. You can see it's a little more than 100 milliabsorbance units, so that's a little more than 0.1 absorbance units. So that's a nice robust peak. Since I injected only salicylic acid, I only expect one peak. If you had a reaction mixture with 2 or more molecules that absorb in the UV, then the relative sizes of those peaks can tell you how much of each molecule you have. On this side now, my run is going. I can start cleaning up, making ready for either my next sample or somebody else's sample. So I can remove the syringe. I'll flip the lever back up. I will squeeze the remaining solution in here, just into a Kim wipe. Wipe off the needle. Now I'll take some 50 star I'll pull up. It's very important I never push anything into the 50 star. Like if I were to push this back in now, I just contaminated it for everybody. There's a little bit of my salicylic acid in here. I don't want it to go back into the stock bottle. But I can use this to flush the loop. I'm flushing the loop, meaning cleaning out my sample. So I just put 40 microliters of 50 star through there, and I'll do that again. So that should mean the loop is clean for the next person. It should mean the syringe is clean for the next person. Put my clean syringe back in the rack. It should snap in. Ready for somebody else.